I'm Julia. I'm with the Ocean Health Index team, and today we're going to walk through a hands-on training with the toolbox. And so I just want everybody to be able to navigate to where the materials that we're going to be using today. So let's see, hopefully this will, that little bar will go away. But so when we're at the Ocean Health Index website, which is the science website is OHI-Science.org. If you go to the resources and then the training page, you'll get to the toolbox training materials. So that's where we're going to be today. So I've already got it open in another tab here. And so what this looks like, I think some of you might be familiar with this already, but this is it's a training book that we've been writing. That the idea of it is that, you know, I can use it to teach, or you can use it to teach, or it's written to tell a story, and if you're reading it on your own, so that it is a resource to you well beyond this training here that we're going to do today. So we're actually going to jump ahead and go through chapter 8 today. There's quite a bit more information in the previous chapters about how to prepare data, how to think about what data to include, and then also how to prepare data. But today we're going to walk through chapter 8 together. Okay, so the way I'll be, since I'm screen sharing, I'm going to be both showing little sections from the book when necessary, and then the rest of the time I will be in R working through the toolbox. But I want you to know that everything I say is written down in here, and I'm also constantly updating this and improving it. So if I think of something that I say that is not in here, I'll also add it. But hopefully this will reduce the amount of notes you are taking, and you can follow along. Okay, so the purpose of this chapter is we're going to walk through the basic workflow that the Ocean Health Index Toolbox uses. So this means that we'll be walking through a tailored repository, which you both have both a Kenya and a Tanzania repository. Today we're going to be working with a demo repository, just so we can all play with it and not worry about messing anything up. And this tailored repository uses an R package that we call OHI Core, and that's what's going to bring all of your data and models together to calculate the Ocean Health Index scores. So we'll show you what that looks like. So we're gonna walk through the same workflow 4 different times today. So we're gonna be practicing it, and we're going to be building on complexity each time we go through. So the first time we're going to download this demo repository and go ahead and calculate the scores just with the data and models that come with the repository. And that data and models are based on a recent global assessment. And then we're going to walk through it again after changing some data, explore the files more deeply, and then we're going to actually change some of the models. And then we're going to finally walk through with new data and models together. So yeah, this is, I've also been, we're constantly improving the way the toolbox works, and also the way we teach it. And so there is a new file that is in this demo repository that we're going to work with, and I will be updating your Kenya and Tanzania repositories so that you have this same file. It's a single file called calculatescores.rmd, whereas there used to be 2 different files that were used instead. So I've simplified this a little bit. So yeah, it's a lot to cover in this training, but hopefully this will give you a taste and confidence to move forward using this on your own. Okay, so the prerequisites, if you're going to follow along on your computer, are to have updated versions of R and RStudio on your computer configured with Git and Github. And I think a lot of you already have this. Here are resources to do this on your own. And then for this demo specifically, we're going to access this Toolbox demo repository and clone it to our computers. So this is for demo purposes, this is a two-step process. So I'm going to show you what that looks like right now, and then you'll be able to do it on your own in the future. So if we go to this this link, github.com toolbox demo, this is a repository that looks like this. And it has the same file structure as your Kenya and Tanzania repositories. So if this was your Kenya or Tanzania repository, you would have permission to edit this, this repository, because I've given you permissions. So at that point, you would clone or download this directly here. But because we want to use this as a demo, we're going to actually fork this into our own workspace. So I'll show you what that means. This is a feature of GitHub that lets you play around with other people's code and build off other people's code without needing permission to do so. So we're going to take advantage of that. So you can see right now this Toolbox demo is in the OHI-Science repository, and that's also the URL up here. If I press this fork button up in the corner here, that means that I'm going to essentially copy this repository into another one of my workspaces. So I have several different workspaces, but my username account is here. So if I click on my username, it's going to essentially copy this repository into my own workspace. So now you'll notice that this is my GitHub username with the repository name, and the URL has also changed. And it actually shows you where the origin was. But this allows me, now I have permission in my own account, so I can modify this as much as I want. And this, when there's multiple people like you all modifying things at the same time, because I want you to be able to walk along with it, this will let us all do this in our own spaces and not have any kind of conflicts with each other. Okay, so the way we, so that's the first step, is to fork this into our own account. And then the second step is to clone the repository. So what we do is, from our account, we click on this green button. And this is going to give us a couple of options of how to either clone or download. We're going to clone the repository, which means we want to copy this, URL. So you can either highlight the text here, or if you click this button, it will copy it for you into the clipboard. And now to actually clone this to our computer, we're going to go into RStudio. So if you can open RStudio right now, here is the, let's see if I can get rid of this. I don't know how to make that smaller, but anyway. So this is what RStudio looks like when you first open it. We've got our console over here. We have our sort of file pane navigation and other features like plotting and looking at packages and help over here. And then this is where we'll have our environment. This will show our objects as we create them, and there's some other features up here. So to clone our repository that with the URL that we just copied, one way to do it is to go up here in this top right corner where it says project. This, depending on what you've been working on, this might say something different, but if you click on this little pull down menu, you'll be able to say that you want a new project. So if people who are following along want to click on this with me, we'll click on new project. And then at this point, we'll get a pop-up window that will ask you what kind of project you want. We want one with version control because we're bringing this project from GitHub. So if I click on version control, I'll get a new window and it will ask me what kind of version control. We're going to be using Git. So you click on this one, and then this is a chance to paste in your URL. So I had copied this URL, that's my username and the toolbox demo.git. So I paste this in the top bar here. Then I can actually, if I press the tab key, it will auto populate the next directory name, which I want it to be called the same thing, so toolbox-demo. So you can either type this in, or if you press the tab key, you'll have that autofill. And then you can choose to save this somewhere. So we recommend that you create a folder in your home directory called GitHub. That's all that's all lowercase. If you don't do that today, that's fine. And we're also improving our code so that this isn't going to be a requirement anymore. But this is what we recommend for now. And if you want to change this, you actually can't click this. You have to click to browse your file system, and then you can figure out where to put it. Okay, so if that's all good, I'm going to press Create Project, and now, so RStudio is going to do some magic in the background, and then you'll see. Let's see. Let me bring this down here. Then you'll see that my my RStudio session looks pretty similar. I've got the console over here, but now my my file system, I've actually been navigated to where I saved this Toolbox demo repository, and you'll see that there's these files here on my home computer that match what was here online. Okay, so now we've got our Toolbox demo clone to RStudio. Okay, so I'll just there's a whole chapter 6 about the Toolbox ecosystem and just kind of walking through all of the files there. But I'll just give a little bit of a refresher before we get started. Let me go into RStudio. So you'll see that here with the files that I have in my folder, in my repository, there's a prep folder, which if you click on this, these are basically empty folders by goal so that you can potentially prepare data. And there's some examples here in this demo repository, but this is where we recommend you don't have, this is like a additional part of the toolbox. It's not required for the calculating scores, but the idea is to script as much of your data preparation as possible, because you'll likely have to make changes, and it's much more streamlined if you coded it, and also it's trying to set us up to do repeated assessments if those are going to occur. So that's what the prep file folders are, and they're you can see that CP, CS, and HAB are together, and that's because those goals are modeled differently, but the data underlying them are often the same, so the preparation doesn't need to be repeated. Okay, so that's the prep folder, and then you'll also have a scenario folder, which in this example is region 2017, and within this is all of the sort of architecture that the toolbox needs. So there's this calculate scores .rmd, and like I said, in previous versions it's .r, and that's the way Kenya and Tanzania are right now, but I'll be updating that. But it works the same way. I've just been trying to streamline it. So let me just check this alert. Check the chat. Volume is a bit low. Okay, let me put on some earphones so that my microphone is closer. Thank you, Michelle. Okay, I hope this is a little bit louder, and I can try to speak louder as well. Let me just check, make sure you can hear me. Okay, perfect. Thank you. Thanks for the feedback. So this is calculate scores, where we'll be working in today. And the other important things that we'll be interacting with today are the conf folder. And this has, this is where functions.r is, which is where all of the goal model functions are. So this is where the code to bring the data into those equations are. And then there's other information about pressures and resilience that we won't get into today, but that's all in this configure folder, this conf folder. So you can see when I click into a folder that this shows me the path where I am, and I can always click back by clicking on the folder that I want to go back to. So that's a nice little way to navigate up here. There's also layers.csv, which is where you register the data layers that you want the toolbox to know about. And so we'll be looking at that a bit more later today too. This layers folder is where all of the data layers are. These are the prepared layers for the toolbox. So anything that you prepare in that prep folder will have to be saved here in order for it to be used by the toolbox. So again, to go back, I could click here. I can also click this little link to go back up one folder. Scores.csv is where the output is going to be saved when we calculate scores. So we'll have a look at that later too. And then we've also got a reports folder that has, it's where we'll put our figures. Okay, and then, so those are the most important things in here right now. Another, I guess one other thing is in here we've got the spatial file represented as a GeoJSON file. And actually, if you navigate here through github.com, this file will be, you'll be able to see the spatial regions, which is kind of a nice way to do it. And then we also have just a region list. So we can, if we click on a CSV here, it will ask us if we want to view a file or import a data set. If we just want to look at this quickly, you can see in this example for the toolbox, we've got 8 regions that we'll be working with today. So just to give a sense of this demo repository. So when I click on this, it will open up in this editor space up here, and then I can close it again. Okay, so that's a little reminder of the toolbox file system. And this figure is a lot to take in, but the idea is that there's this workflow associated with the files in the toolbox. So there's a lot of work that happens before the toolbox that we're not going to talk about today, but preparing and registering data is something we're going to touch on quickly today. And then modifying goal models is something we'll talk about today. We won't be talking about pressures and resilience. And then calculating scores. So this is the workflow associated with what we'll talk about today. And then trying to match this workflow are the files that are involved. So if you're in your repository, when you're preparing and registering data, that's mostly going to happen in the prep folder within a specific goal folder. Usually, we recommend scripting it with an R script. And that will be saved to the layers folder, and you'll register it. And then as we're going to be modifying goal models, that happens in the conf folder in this functions.r file. And we take all that information in order to calculate scores through this calculate scores.rmd, which will then produce scores. So that's the workflow as a picture, and now we'll actually do it. I'll stop talking about it and we can actually do it. Okay, so first of all, we're going to calculate scores using the data layers and model inputs that come with the repository itself. So let's go to our studio session. If we navigate back to the toolbox demo home folder, and then into the scenario folder. So right now we're going to be in this region 2017 file folder, region 2017 folder. Let's open this calculate scores .rmd. So if you're not familiar, so an RMD file it's called an R markdown file, and it's a really powerful tool that we've been starting to use more in R because it lets you combine written text in this case in English alongside code. So it lets you document your thought process a lot easier than just looking at an R script, for example. And something that's really neat too is that this is a slightly formatted file here, but it can actually be rendered into a website or a PDF or a Word document from this file itself. So this is how we create those websites that for Kenya and Tanzania as well. But anyway, so there's text in white and then actually code in these gray code chunks. And what makes a code chunk are 3 backticks, which on my keyboard is right above the tab symbol. So there's 3 backticks on either side, and then these little curly braces say R. Anyway, but this lets us run code line by line like we would in R. And it also lets us run an entire chunk of code like this by clicking this little green button. So this is going to help our workflow today, is because we're going to be able to click these buttons to run whole chunks of code as we go through. So to get started, okay, yeah, so let me just give you an overview of this file. These headers sort of walk us through the workflow of this calculate scores.rmd. So first of all, we're going to be installing R packages. And this is something that you do just one time. So I think of this as like wiring a building for electricity. You do that one time. You don't need to do that every time. But what you do need to do every time you want to use this code is you'll need to load the packages, and that happens with the library function. And I think of this as like turning on the lights when you come into a building. It's something that you do every time you come in. So we'll run this, we'll load the packages. Then we're going to configure the toolbox, and we'll walk through all of this code. But this is a code chunk here that's using functions from the OHI core package. And then there'll be, after the toolbox is configured, we're going to calculate and save scores in this code chunk. And then finally, we can create some figures as well. And I've started writing out a little example workflow as well that I can improve in the future. But so that's what's in this file. So why don't we go ahead and run this code. So the way I think let's run this line by line. The way you do that is you can highlight a line and click run. That's one way you can do it. So if I click run, and it will ask me actually, what do I want to do? Run selected lines. So I can say run selected lines, and you'll see that what's happening is that, let's see. Let me move my pane up here a little bit. You'll see that this line of code is actually passed to the console, which is where all of the, that's where the engine of R is. It's where everything goes to be executed. So for me, this happened pretty quickly because I actually already have it installed, but this might take you a while. So I'll walk through each of these. Yeah. How about everybody who's following along, runs through each of these on their own, and we'll figure out when everybody's installed. But I'll continue doing it myself too, but you can go ahead of me if you need to here. So then you'll install this package zoo. And again, you can hit this run button. There's also a lot of keyboard shortcuts. So one of the keyboard shortcuts is to, let's see, I think it actually even says it here. Yeah, so this will, on my computer, this is the command return keys. This will actually run, if I hit command return on my keyboard, it will do the same. And on a Windows, it should tell you here, but I think it's control return or control enter. And also our studio is smart enough that even if you haven't highlighted the code, but your cursor is on a certain line. So here, I can do the same. I can press run selected lines, and it will know that it was on that line with the here package in this case. So I've installed Tidyverse Zoo here and now I'll do DevTools. These four are packages from the R community, and this is from, you'll find these on the CRAN repository if you're familiar with R. Just while we're waiting for other people, there's also a way for you to go over here to the packages pane and install packages by searching for them. So you could type in a package that you know exists. Like if I write DevTools here, it will actually predict for me what I might want. I could select it and I could press install. And so if I do this, it will do the same as what I've written here, but it's a way to, it's another way to do it, and you can browse from different places as well. Okay, so those are from the R community. And then also we, as the OHI team, have been able to create an R package that you can install directly from GitHub, because that's where our code lives. So to do that, you'll run this line of code just the way we've run the other ones, but you'll see that the way we install it is slightly different. Install GitHub as opposed to install packages. So if I run this, it's going to download from GitHub and hopefully install without any problems. Yep. So this one will actually say when it's done. So let me pause there and see if there's any questions from those of you who are installing. I know this tidyverse takes a little while, so we can wait. How's it going? Does anybody have any feedback where they are in the process? Will you let me know when you're done, or if something is giving an error?
I think everyone's just waiting for them to install.
Okay. 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 Well, I can continue, and then just in the interest of time, and then because the next step I can talk through, and then we'll be able to run it all at the same time. Because this, like I said, this install packages is something that now that you've done it this one time, you won't ever have to do this again. And in fact, if you want to afterwards, you can comment all of this out, so you won't run it by accident again. So in R, the way you comment things out is to use these hash symbols or these pound keys. So you could either write this, you could either add one to the beginning of each of these lines. Something else that's nice in RStudio, this is a little, I love showing little shortcuts, so I'll show you this while we wait. If you highlight all the code you want, you can go up here to code, and then there's a command for commenting or uncommenting lines, and there's also a shortcut for it, which is on my keyboard Shift Command C. So if I press this, it will add all of those comments for me so that I don't have to do them one by one. And actually then with this shortcut, Command Control C, if I do this on my Command Control C, if I do this on my keyboard, I can sort of toggle them back and forth, turn them comment on and off. So that's something that's nice to know. Okay, so I'll assume that that's still going for you, and so then, but every time you'll use this calculate scores.rmd file in the future, you won't have to do the installing, but you will have to load these libraries. And so what we'll do, you can also run these line by line the way we did just before. You can also highlight whole chunks of line or whole groups of lines and run these all together. So you'll see I can send multiple lines to the console, and it will give me some feedback depending on what the package is. So there's a trend towards providing more and more feedback when you load packages, so that you know what versions of everything you have. So all of that is fine. And then the last step is to set our working directory. And the working directory is something that you're probably familiar with already when you are working in any file, whether it's Word or Excel or any kind of thing. When you go to save it, it's going to ask you where you want to save it. And in R, you have to be pretty, it's good to be aware of where you are now and then where you might be saving things or accessing things. So in RStudio, there's a couple different ways where they help you see where you are. And the first place is in the console here. This will show me where I am. So this is my home directory in this GitHub folder that I created, and then the Toolbox demo. So this is where I am all the time. And even though in my file pane, I'm navigating to different places to look at things, I can do that all I want, but that won't change where I am. But the way you do change where you are is there's a function called set WD for set working directory. And this is where we're gonna use this new here package that is actually going to, if I run just these lines inside the set working directory parentheses, if I run this, I think I can run just, yeah, if I run just this here thing, you'll see that this will give me a file path that is unique to my computer. If you all run this, you'll get a file path that's unique to your computer. But this lets us collaborate across computers because the R knows this full file path with my name on it and your name on it, but it will let us be able to operate without being reliant on our file paths that are specific to our computers. So if I run this whole line, not just looking at where we're going, where the working directory will be set, if I run this, you'll see that the place that I am right now has changed. So this has actually changed my working directory and where I am now to region 2017. And just to show you while we wait to the way you can ask R where you are. So set WD is for setting it, and then to ask where you are, you say get WD with nothing inside the parentheses. And if I do that, it will also show me where I am. And that this little tilde is the same thing as my users / Julie Lowndes. So that's what the equivalent is there. Has it installed? Have those packages installed yet? When your packages have installed, instead of running all of this line by line like I have right now, why don't you go ahead and take advantage of this play button up here, this green triangle, which instead of having to highlight code or put your cursor places, if you press this here, this is where we are now. If I press return here, if I press this green triangle here, it's going to pass everything in that chunk down here and do everything again. So that's a way for you to catch up. And that's what we'll be doing for the rest of the training, is always loading these libraries just all together as this nice chunk.
Hey, Julia, I think everyone's packages have installed.
Perfect. Great. Okay, excellent. So why don't you then come to this loading our packages chunk and click this green triangle so that you'll load all the libraries. So you'll turn on all those lights, and you'll set your working directory to be region 2017. Great. So that's all stuff that the toolbox needs, but it's kind of outside of the actual inner workings of the toolbox. But we can come down here to configure toolbox, and we're going to walk through each of these things line by line in in a moment, but right now what I want you to do is also run all of this code together. So I'm going to do this by pressing this green button, and then we'll walk through this all again line by line. But right now, just run this green button and let's see what happens. There's like a lot of things that happen in this console when we do that. So so just looking at everything that this reported, there's looks like, so these are all of the data layers that are involved. And then there's some warning message or some information about the data layers that are involved here. So we'll look at that in more depth in a moment. But if there's no errors, that's always a good thing. And then if we go to the next one and actually calculate the scores by clicking this button, you'll see a lot of other output. You see that there's status and trend calculating for each goal. And then there's going to be pressures that's calculated, resilience that's calculated, and then goal scores and likely future state are calculated for every goal. And then there's some final processing of combining sub-goals, goal weights, all this stuff happens. And then there could be some warning messages. In this case, it's because it's because of the data I've pulled into this demo repository. But if there's no warning messages, we'll give you some things to look into potentially. But it means that the toolbox worked and successfully calculated scores if you see this last bit of feedback without any kind of errors. And then this actually also saved scores.csv. And so if we look at scores.csv, you'll see that you can actually see the timestamp of when this was created. So this was a file that already existed here, but it's been overwritten and recreated just now. And I can have a look at it in the file pane again by clicking View File, the scores.csv. You can see that for every goal and every dimension, whether it's future or pressures or resilience or scores, there's a score for every region ID. So for all 8 of our regions, there'll be a score for all of these goals and dimensions. And in addition, actually, to those regions 1 through 8, it's also calculated an overall score for the entire assessment area, it gives a number 0. Okay, so that's a really quick run through of calculating scores. Let's also let's run that last chunk as well to create the figures. This is, you'll see this plot flower is a function that is actually not in OHI core yet. It's online in a different OHI plus repository, which is where we have improved it. But this is kind of a neat thing to know, is that you can access code from online as easily as you can from your local computer if you've got an internet connection. So if I source this file that has this plot flower function in it, I can run all of this. I'll just press play, and it's going to give a little bit of feedback, and then finally we'll see these flower plots show up in this reports/figures folder, which is the directory where I told it to save reports figures. If I go again to this figures, you'll see that these timestamps reflect when these things were created, and you can click on one of them and have a look. Okay, let me check my chats. OHI core not downloading, dependency, get to R. Okay. Let's see, that is, okay. Can you tell me what R version you have, if you're having an error with downloading OHI course. So if you go to the very top of your console, if you scroll this all the way up.
3.4.0.
3.4.0.
That's not the latest one, is it?
Yeah, so I think that error will go away if you update R.
Okay.
Yeah, and so you can do that. There's a link at the top of this chapter, the overview. If you go to, there's a couple of different places you can go, but if you go to this cloud.r, then you can download R for Mac or Windows. I'll show the Windows version. And it's a little confusing, but yeah, you say you're going to install R for the first time. So if you click here, then it'll finally give you the option to download R.
Okay.
And you'll have to close R Studio. So you can do that while it's downloading. You can close R Studio, and then you'll have to walk through all of the install wizard and everything for R. And then when you reopen R Studio, it will have your latest version of R. You don't need to sync it. It will do it itself.
Perfect. Thank you.
Is anybody else having any issues?
Nope, don't think so.
Okay. Great. Okay. Let's see. Okay, so yeah, so then once it's downloaded, you do the whole install wizard, and then when you reopen R Studio, hopefully it will have this newer version, and then it will let you install OHI Core. So I think for you, you'll have to come back up here to line 24 and rerun this, because there was I think this errored when you ran that. Okay.
I'll catch up.
Okay, great. Okay, so let's see, let me go back here. So we have just so I said we were going to walk through the toolbox 4 times. We just did it the first time, this sort of out-of-the-box scores, out-of-the-box data and models. Just with the default data and models that the repository comes from, we've walked through the whole workflow, so you've seen that. But now we're going to actually show you what's actually happening line by line. And we'll do that by adding new data and seeing what changes. So we're going to be in this 8.4. Okay, so what we're going to do is we're going to pretend that we have new data for the artisanal opportunity goal. We don't want to change the models at all. We just have data locally for Kenya or Tanzania that we can substitute for this default data that came with the toolbox. So what we're going to do first is we're going to restart our R session, which means that we're going to go into our studio here, and you go up to session, which is up at the top menu, and you say restart R. And what this does is it's gonna turn off all the lights, so it's not going to have any of these packages loaded anymore. And it will also, we haven't looked at it yet, but this environment pane is where any kind of objects are stored when, or are visible when, as you work. But I think it's really good practice to turn off all the lights and clear out everything you've had on previous runs, so that you can, as we're calculating the scores this time, we can be sure that we're not reliant on something that that we don't expect, or that like our collaborators wouldn't have if we were going to be sharing this later, which you will be. Okay, so let's see. So we've just done that. Okay, so what we're going to do is go back to the Toolbox demo home folder over here in the navigation, and we're going to go to this prep folder. So we're going to pretend that we're going to prepare some data, our own new local data for the artisanal opportunity goal. So in the AO folder, you click in that, we're going to click on this access_prep.r. And when you click on this, you can navigate, you navigate there by clicking through the folders, and then you can click on this .r script, and then we'll have this R file open up in our editor pane up here. And essentially, this is a little dummy example where we're going to be preparing our local data. But this is an example of how data preparation could look like for you if you're going to be doing this in R. So this is an R script as opposed to an R Markdown script. So you see that any kind of instructions or anything I'm writing has to be prefaced by this by one or more hash symbols, so that R doesn't think that it's code and give me grumpy error messages because it thinks that this is supposed to be R. Anyway, so this is an R script. So you'll see that at the beginning of any R script, you'll load the libraries that you'll need, and so this is becoming kind of common practice that people use, where they'll just have the libraries that they're going to load, and then if you don't have that library, they give you the code that you would need to install this. So this is something common that you'll see more and more. I separated them in our calculate scores script, but this is another way you can do it. Anyway, so what's going to happen in our prep script is that we're going to load the libraries and set identify the file path for the layers folder, which is where all of the data layers finally will need to be saved. And then essentially what my this dummy data layer that I'm going to create is what I'm going to do just for our purposes is I'm going to read in the layer that's already there, which is called, for this AO access data layer, has its data from the global 2017 layer, assessment. I'm going to read that in, and then I'm going to overwrite the value with random numbers, and then save that file again. And this time I'm going to save it with a name demo at the end. So this is our focus today isn't really on data prep, so that's all I'm going to say about this right now. But that's kind of the work. That's a workflow that you could have as well for your data prep. You would set your libraries. You'd read in the data that you have from whatever data source. You'd have to do some kind of summarizing potentially if you're averaging or whatever you need to do, and then you can save it directly to the layers folder. Okay, so in an R script, there's not a little green triangle to run, but what you can do is you can press this source button. You could also press, I guess this run button now only works line by line, and so I had my cursor somewhere that it wasn't happy about. But I can press this whole source function, this whole source button, and it's going to do every single thing that, let's see, it's going to do every single thing that I wanted starting, sorry, so this error message was earlier. So this is the call I just gave it. As I said, source this whole file, which means run everything inside the file, and it returns no errors because everything was fine. I could also highlight everything and then press run, and then I'd be able to see everything that happened if I wanted to, but yeah. So what this did was this eventually saves a file called AO Access Demo 2017 in our layers directory. So we could go over here and see this. So in our Toolbox demo, we go to our region 2017 folder, to our layers folder, and you can see I have this organized by time. So you can see the demo folder, or the demo CSV that showed up here. Another way we can see this immediately is if we look over at our Git tab. So this Git tab is watching our whole repository, and anything that changes to it is going to show up here in this tab here. So to me, when I expect, I've just created a new file, I expect it to show up where I saved it, but I also expect Git to see it. So this is a way that I visually just check to make sure that things are happening the way I think they should. Okay, so we've saved a new data layer. It's kind of a 3-step process to save new data into the toolbox. The first step is to actually create the data and save it in the layers folder. The second step is to register this in the layers.csv folder. Sorry, the layers.csv file. So let me show you here. So the first thing is to prepare and save our data layer, which we've just done. And then we'll be registering this in layers.csv. So what we need to do is layers.csv is inside the region 2017 folder. And unfortunately, it's too big. We can look at it in RStudio, but it's pretty terrible to look at. It's much nicer to look at in Excel or something similar. So sometimes for quick things, I'll edit them here, but most of the time I'll go to Excel. So let's do that right now. So I'm going to go to my my file pane here, just on my computer, and navigate to my Toolbox demo folder. And then it's within the region 2017 folder, it's layers.csv. And if I double click there, it will open Excel. I think I didn't click it. Okay. So this is layers.csv is kind of the registry for data layers. So everything that's listed in this file is a data layer. Every row is a data layer that the toolbox is going to use. So you can see that some goals have multiple layers. There's always many pressures and resilience layers that are associated with the single goal. Yeah, so there's these targets which show which goal things are associated with. The layer name, which is a shorthand name for the data layer, and then there's also a file name. So this is the registry part of it. It's saying for every layer that the toolbox uses, every layer is going to be associated with a goal, and it's going to have data behind it. And so this is where to register our new data layer, this is where we're going to find our AO access data layer, which is the first one here. And right now it's going to be looking for data from this GL 2017 file, but we want this to be our demo 2017 file. So just in Excel, you can edit this file to say demo 2017. And hit return. I'm going to make sure that that's actually what we called it, just to double check. So it's AO Access Demo 2017. So you could also program this if you wanted to from that prep file, so that you don't have to open this Excel file, because there's obviously potential for error, but it's also, I find it kind of satisfying to be able to open this and look at it. So it's up to you. Okay, so now that we've added this, I'm gonna save this file, and because it's a CSV, there's kind of these weird things that happen on a Mac. I think it's on a PC too, but you have to say yes, continue, and it will save it. And then when you go to quit Excel, it will ask you again if you want to save it. And I say no, because otherwise it will try to make you save it as a Excel file. So I'll assume that everybody was able to do that. And what you'll see, so since I have this RStudio window open like this, you'll see two things. First of all, you'll see that my layers.csv shows up in my Git window. Like it, even though I made those changes in Excel, Git knows that something within my folder changed. So it shows up here, and you can actually look at this little, oh, it's not going to present it very nicely. Okay, never mind. But you'll see that it shows up here, and you'll also, since I have the file open, you'll see that it was actually added here already. Okay, so assuming that that worked out for everybody, so we just registered the data layer in layers.csv. The last thing we have to do to register is we just need to make sure that the years of data that we have are correct. So we're going to open up this file called scenario data years.csv. So if we go to RStudio, this is in the configure folder. And it's called scenario data years. So this is a small enough file that I can actually view it in RStudio. And what this does is for every layer, there's what we call a scenario year, and then there's also a data year. And what this means is that right now there's about 100 different data sources in this assessment repository, and not all of them are going to have data reported for 2017, which is when we're going to do our assessment. So there's different, there's oftentimes if data are reported, it's reported maybe a year, there's like a year lag when it's reported, or maybe some things aren't updated every year. So this is a way to register where data is coming from. Since this is from the global assessment, we've got many years of data in here. You need at least 5 years of data to calculate trend scores. So that's why you see these multiple years of data here. But what we're going to do right now when we look at this is to see that our AO access layer, we want to make sure that there is data available. There's a data year available for 2017, which is when we have our assessment. And so we can just look at our layer that we just created and confirm that we haven't actually looked at this data yet, and this is just a dummy data, but 2013 is the only year of data that's available for this data source, let's say. And that's why no matter what the assessment year is, the years of data that we're using is from 2013. So this is an example of a data source that is not updated and is not ideal for tracking change through time for the Ocean Health Index assessment. But this is something that you can improve on a local assessment, and that we're hoping to improve in the globals. So this is kind of bookkeeping. I'll leave it at that so we can continue on. But right now we didn't change anything to this file. We just wanted to confirm that 2017 was represented with this data layer in this scenario data years. Okay, so we have, so right now this looks good to us. We've got this new data layer saved in our layers folder, and we've made an update to layers.csv. So I'm going to close these things, and you can leave them open. It doesn't matter, but just so I can navigate over here again. Let's go back to calculate scores. So what's happening in our console? We've just run our prep script. That's happening here. So we're about to rerun our calculate scores and do the same workflow we just did after making this update to the data. So before I run calculate scores, like I said, I like to restart my R session so that nothing is in it. And actually, if we look at our environment before we do that, there is some like, Ds and D2s in here that were a result of that data prep script. And I don't want them of potentially, getting in my way in when I calculate scores. So I'm going to restart R. When I do that, now that I've got the environment pane open, you can see that all disappears and that my R session starts over. Okay. So now here in, if we go back to calculatescores.rmd, we can actually just start with this second chunk of code where we're turning on these lights again with the library. So let's together press the green play button and load all of our libraries. And then we'll, now let's, okay, now let's run this line by line now so that we can see what's happening instead of running it as a huge chunk. So if we run this conf line on line 49, I'll press it, I'll send it down to my console here. So what's happening here is this, this is creating an object called conf, and you'll see it showing up over here. This is essentially taking all of the information from our goals, it's taking information from the conf folder, including information from goals.csv and functions.r, and all of the pressures information from the pressures matrix and resilience matrix. It's taking all of that stuff that right now is in separate CSV files, and it's saving it into one object that will be used in the future. So that's about as much as you need to know about it. It's something that it also is checking to make sure that there's no problems with the code and your goal models. The next thing that it's going to do is this is when we're going to check. We're going to check that all of the layer files in the layers folder match that layers.csv registration. So this is actually really important if we run this. Well, all of these are really important, but this especially. So I'm going to run this line, check layers. This is when it will, the output is it will go through every single row in that layers.csv file that we were looking in Excel. It'll go through every single row and make sure that, first of all, the matching file exists. So it will actually look to make sure that the file that was registered exists here, and that it has data for every region, and that it will look for the column name, and it's doing a bunch of checks now to ensure that if you get errors or you need to troubleshoot later on, that this won't be the problem. And so this is really important. This is like a sort of a gatekeeper that we put in early on when we found ourselves having difficulties troubleshooting, and we were trying to figure out if it was a goal model or what was going on, but it turned out to be just the way the data was saved. So this is like a nice safety net to make sure that every single layer that is there is appropriately formatted and saved. And it will give you some updates. So here's, in these cases, there's a couple columns in certain data files that are never used. So you could clean this up if you wanted. This is residue from the global assessment. Okay, so that check layers, that's the sort of output that you'll get. And then finally here, we'll create a layers object. So let me run this. When we run this, there's not really, there's no errors. So there's not really any output right now. Well, this will be taken care of in a little while. So I'm not going to talk about this right now. Okay, and then this last thing that happens is that we set the year that our assessment is representing. So this is called the scenario year, and we were looking at this in that scenario data years file too.
So this right now it's a bit overkill for us in this demo and for Kenya and Tanzania right now, because you're doing a single year of an assessment. But what this is doing is this code is setting us up for being able to do repeated assessments more streamlined in the future. So if you're going to be calculating multiple years of Ocean Health Index scores, this will come into play later. But for now, it's a little bit, it seems a bit clunky, but there's a reason for it. So if I run this, that's what's happening in this whole chunk. So it's configuring everything. It's grabbing all of these layers this whole chunk is grabbing all of the layers that are here and saving them in a big object that will be available later. Then it's taking everything from the conf folder and saving it into an object called conf. So it's preparing us to be able to calculate scores. Okay. So now let's come back here and run the scores here. So now when we run this line, so I'll pass this down here. Again, it's going to walk through every status and trend for every goal, pressures. This looks the same. We didn't dive into this very deeply the first time, but this looks the same as before. The AO goal was calculated just as it was earlier. There's nothing fancy about it. It's just using new data, but you don't see that in this output here. And you can see that this scores object was saved. So you can always look at an object when it's a data frame up here. So I could click it on this scores object and I could look at how, the AO goal was calculated for all of these dimensions. And then the last thing to do, I'm gonna go back over to my Git tab so we can keep an eye on anything that changed. I won't talk about this that much, but you can, within your goal functions, you can have it save output if there's things you want to look at later. So this is for the fisheries goal. They're looking at there's some summary information that we're going to save as well. So that's what's happening here, but don't worry about that. The last thing we'll do is actually write this scores object to the CSV and overwrite that. So if I run this, this resaves the scores.csv, and you see that the timestamp changes. But what's so powerful about using GitHub and this whole workflow is that, the scores.csv, things changed within it line by line, and we can actually use GitHub to kind of check that just by eye. So if I press this diff button when I'm highlighting a certain file, it will show me the lines within that file that changed. And so this is a way that I can kind of check to make sure that, I added new data to AO. I expect that AO changed and probably the overall index score changed. So if I look at this, it will show me in red is the previous information that's now deleted. So for example, on line 27, the overall score for my whole assessment area for AO used to be 97.4. And now it's 93.69 with my new data. So this is a way, if there's small changes to a file, you'll be able to glance at them here and see what to match what you expect to change with what changed. So here, as I said, I'm expecting AO scores and status to change because I had updated the data behind them. And then I also, down here, I expect the overall index scores to change slightly. You can see that this is slightly, 74.62 versus 74.24. Like there's been a slight change in the overall index score because of my addition to AO. And I can see at a glance that those are the only two changes that happened. But this is a good way to error check, because if something had changed to my fisheries scores, I would know that there was I've got a problem somewhere, because there shouldn't be, maybe I introduced a typo somewhere in my code by accident. And this is a good way to check if that score changed. And then also you'd be able to figure out where what other files potentially changed here. So that's super powerful. And then also let's recreate these flower plots too. When I run this, again, those files will show up here, but you'll see that now since they've changed, GitHub also knows that they've changed, and they'll be watching the figures as well, now that there's new information for artisanal opportunities.
Question?
Yes.
So in the code, the line 59,
Yes.
you've got $2 so layers, data, scenario.
Yes.
What does that do? Why
yes.
do you have lines?
Yeah. So this is so this layers object is actually, it's a list. So this is getting into kind of the like guts of R and how it saves data, but like I can't click on this layers thing the way I can click on scores here, because this is a list. So if even if I write layers here, it's going to give me kind of funky information that it's hard to interpret. But the way these dollar signs are a way to access information stored within an object. So this is like a way that like this is like a fundamental syntax in R. So if you write if you know that there's something inside your layers object and you write a dollar sign, when you're working in RStudio, it will help you, it will know what's in there. So all of these things, I don't even know what all of these things are, but these are all part of this layers object that contains all of our data from all the layers. So if I say data, if I hit return here, it's going to show me, this is all of the data from all 100 of those CSV files, all like, collapsed into a single place so that the toolbox will be able to access it really quickly when it needs it. And then within that, there's the second dollar sign then lets me identify a certain piece in here. So I think that I could also do, let me see if I can just take one of these here. If I copy that, I think I should be able to say layers, dollar sign, data, dollar sign, and then paste that and just get the information for us for a single file, essentially, a single layer.
Okay.
Yeah.
I mean, I've seen the dollar sign, obviously. I've used it when it's a frame and you want to access maybe a column.
A column, uh-huh.
Never been used twice, so it's useful.
Yeah. It's I don't work with lists a lot, and we don't use this syntax very much. This is, like I said, this kind of this like little clunky way of inserting the years into our layers object, so it's available. Yeah.
Okay. Thanks.
Yeah. Okay, so we've just run through this and created our new scores and our new flower plots based on our updated data. And so let's all now push this back to GitHub so we can practice that. And then we can also, you can actually see the differences in figures when you're on github.com. They're not able to show you that difference here the way they were with the scores, but when you're online, they can. So we all are working from our own repositories, like our own user accounts. And so we have permission to push this stuff back to GitHub. So what we'll do is, I won't focus on this right now, but committing and syncing to GitHub has several steps involved, which the first of which is to select all the files that you want to sync. So you have to put a little checkbox by all of these that you want to sync. And luckily, you can also do Command A or Control A to highlight all of them. And then you can press this stage button, and that will check all of the boxes, so you don't have to walk through and do every single one of them. What I'm going to do right here is, let's see, let's write a commit message here and say update AO data for AO access rerun scores. So you can write some kind of little message to yourself that, so you're required to write a little message to yourself. It can be as short as you want it to be, but there's kind of a sweet spot of having it be short but memorable, or for you in 2 months to be able to look back at this and to see what changed at what time is kind of nice for yourself, so you can be nice to your future self who has to look at this potentially later. Okay, so once you have a message and you've staged these things, you can press commit. And what this feedback is here is if it doesn't give you an error, that means it worked. So it gives you a bunch of information. It's going to do a bunch of back-end stuff to organize and send all of this stuff to github.com, and it kind of tells you what's going on. So I can close this. This is still local on my computer. I haven't synced it online yet. I've only captured this moment in time with all of the files that changed at the same time. So what I have to do next is push, which is how I push this back up to the cloud. What I recommend is that even before you push, that you always pull one more time. In this case, I'm working from my Jules 32 user account, and I know that nobody else has worked on these files, but you all are going to be working on the Kenya and Tanzania repositories, and it's possible that somebody else has made an edit since you've last interacted with github.com. So it's good practice to pull. I'd say pull as much as you want. You can't pull too much before you push. So what's going to happen here is it's also going to, if there's not an error, that means it worked. It's just going to give me some more details here. But what's cool, just to show us how we can use github.com to also review all the changes we made. If we go here to github.com and go back to my user account, right now it looks like nothing's happened. It says, Jules 32 did something, but it's been 2 hours ago. But if I refresh this web page, it's grabbing the most recent thing. And here's my little message I just wrote: update AO data for AO access and rerun scores. This happened 2 minutes ago. So at a glance, you can see what's changed. What's nice here too is that when I first look at a repository, I immediately look at how recently something's changed to it. And then you can also look, folder by folder, file by file, how recently something has happened. So immediately I know that something has changed within my region 2017 folder. So there's a bunch of different ways we can navigate through github.com. I'm not going to show you very many of them today, but I just wanted to show you that up here with the commits, this is actually a record of all of those messages that I've ever written. So you'll have a bunch of these too from me as I've been developing this toolbox demo. But this is the most, you will have your own commit message about what you've just done 3 minutes ago or so. And you can see, so this is basically a history through time of the way the repository looked and the files that changed through time. And so there's a bunch of different ways you can access this. This will, if you click on these symbols here, this will let you actually go back to the way all the files looked at that point in time. This will let you see that sort of green and red of what changed by file. So if we look at the green and red of what changed 3 minutes ago, you'll be able to, you see like a more fine-tuned amount of information of what changed. So even though in RStudio, when we tried to look at layers.csv and it was all red and all green because it's checking data and like kind of overwriting columns, here you'll see that it's actually just one line that changed and then actually just one file name that changed. So that's kind of nice at a glance just to see what's happened. This is really good for error checking if something's not working the way you expected and you just want to see. You can also see we added this file. So this is our demo file. So it's all green. It's a brand new file. And then what's cool is that these figures, you can actually see these. Oops, that's not the right button. I don't always press the right button. Okay, let me go back. This will let you look at the figure as it is right now. But I like to look at, you can look at the difference. Let's see, display, okay, there we go. So you have to click on different buttons. But you can see that this will actually let you see like visually, like it can look at graphics and see that, you know, we started off with this score that was 75 when artisanal opportunities was dark blue to the very edge, and then with our recalculation it got a little bit lighter blue to the edge and 74. So it's just a nice way for at a glance seeing what's going on as you progress. Okay, so let's go back. Are there any questions at the moment? I know this is okay. Okay, great. Well, let's go back to RStudio. We can close our GitHub window here, and we're back to a clean Git pane and all these things in our environment. Okay, so now let's see, let me come back here for a second to, okay, so we did this with out of the box, we calculated with tailored data. Now let's calculate with tailored models, and we'll explore functions.r at the same time. I have done this a little bit out of order, but that's okay. So what we're gonna do right now is, again, recalculate scores, but first of all, we're gonna do something different to the models. So let's go first and look at what functions.r looks like. Okay, so if we're back here in our RStudio session, I'm just gonna restart my RStudio session now. We could also do it in a few moments because we're not gonna run anything immediately, but it's just nice to, you know, once I push stuff to GitHub, you know, it's like a clean slate. So I like to restart. Okay, so let's go back to region 2017 here, and then in our conf folder. So functions.r is what we're going to be looking at right now. So let's open this up. So functions.r is an R script that is full of functions. Every single goal model, every single goal has a function associated with it, and the goal is going to be identified by the 2 or 3 letter code. And what this means is that, so every single, I guess I have said that already, but every single goal, like the status and the trend, are within these functions. So something I like about RStudio is you can click down at this little place here and see all of the functions that are available within a file. So you can see that we've got fisheries, mariculture, and then food provision. Let's look at the AO one, since we'll be using that as an example. The way these look, if you're not familiar with R functions, is that this function is going to be called AO, and everything within these curly brackets is the function. So the curly brackets start here and ends here. So this one's a nice short one for our example. And we're still, you know, through time, we've been improving and making all this stuff look more streamlined, but all goals we'll start off by potentially setting a constant if that's going to be used somewhere. So in this case, sustainability is something that we want to include in the AO goal. We don't have data changing through time, but we're going to set it as a placeholder constant until we have better data. Every goal will have to deal with the scenario year to make sure that it is going to be calculated for the correct year. And then it will read in data. So here's, this goal model is going to be using AO access and AO need. And then there'll be the actual goal model. And then finally extracting the status and the trend from that goal model and returning scores. So this is a little example of how the code looks here. Let me show you, let me go back to the book really quickly here because I've got some screenshots I could show you. Let's see. Toolbox. Scores. I'm trying to find my explore functions that are, there we go. So this is kind of what I've just been saying right here. So the goal model itself, from the way the equation is written in the paper looks like this, and then this is the way the R code looks to match. And so it's really nice when the model can match so closely, like the code can match so closely to the model. Sometimes there's a lot more summarizing and analyses that are kind of going on alongside the goal models, but we're trying more and more to elevate those goal models out so they're easier to find. And so what's happening here is that when we run calculate scores, so when this conf object is created, it is taking all of those goal functions from functions.r and storing them into memory, so that when we run calculate all, it's going to combine the data layers with those goal models and calculate the scores. So that's when functions.r comes into play. And so you'll be spending quite a bit of time in functions.r editing goal models to align more with the data that you're adding to the toolbox. So let's do that right now. Let's modify a goal model together and then rerun the code. So let's see. Right now, okay, so let's say, so this is the way the goal model looks like right now. Let's say that we want to do something. Let me go back to my little calculate with tailored data, calculate with tailored models. Okay, let's say that we want to update this code. We'll just do a really simple change to the equation. Let's say that we want to divide du by 2. So we want to add, we just want to make some change to the goal model. This is obviously a really simple little example, but let's go ahead and do that. So what we would do is in RStudio, we would open up functions.r, and we can edit this functions.r directly. So I'm going to write divided by 2 right here in the code. And you probably know this, but in RStudio, when you've made an edit to the file, it will turn red with an asterisk when it's not, before it's saved. So once I save it, it turns black. And also once I save it, it will now show up in the Git window. So I can immediately tell that something's changed here. And I like this because if you ever, hit like type V instead of, Control V or Control S or something, you'll see a file pop up over here. So right now we've got functions.r here. Okay, so now let's recalculate our scores with this updated goal model that we've just done from all of our analysis here. So I've already restarted my R session. I don't have anything in my environment, but if you do, go ahead and restart now. And then So we just repeat all of these steps. So actually, so not install packages, but so we load all of our libraries here, loading the libraries, and then we need to configure the toolbox again. So anytime you make any edits to functions.r or layers or anything, you'll rerun this chunk because you want to be able to have it in memory. And so what's important now too is even before we calculate scores, once all of this stuff is loaded, I can actually I have all the information loaded I need to so that I can run this stuff within functions.r line by line. So this is how you'll be developing these goal models, is you can actually come in here to functions.r after you've created these conf and layers objects, and I can run this stuff line by line. So let's say I want to run this. I can run it here, and so now I've got the scenario, I've got this stuff loaded into memory. Now I can run this line by line, and I can see that this R object, which is not a good name, I guess, has read in my AO access. And so if I looked at it, this is what that access data looks like. They've actually, we used to just have our 2013 year only for each of our 8 regions, but what's happened in this align data years function is that it has copied those years for every single scenario year that we have in case we want to calculate multiple years of assessment. So that we'll only be using this most recent 2017 year, but that's kind of what's going on behind the scenes, is it's setting you up to do repeated assessments if you want. But it's, yeah, so you can work, you'll be working from within this functions.r a lot as you develop your code. So you can run this now line by line and see your RY variable. And so you can see, let's see, I can click on RY. There's a bunch of different ways you can look at this. You can click on RY. I also like to look at the head of RY, which is the first 6 lines, because you get a sense of the data without being overwhelmed by everything. And then we can actually run our goal model and see how things will change. Well, these mutate functions will actually be adding 2 new columns, one called DU and one called status. So let's see what that looks like. If I run that, and then do head of RY again, you'll see that the goal model is being developed right here. It's actually happening for every year, even though it will be using the same access years every year. What the status does is actually, because the models are already calculated here, the status is almost more formatting in this example. We're gonna remove all years except for the scenario year, which is 2017. We're gonna only select the columns that we want. And then instead of having a status that's a decimal, we're gonna multiply it by 100 so that it's between 0 and 100. And then we're gonna add a column called status. So if I run this, we can now look at what the status looks like and see that this, it's now a 3-column thing here, data frame here. The trend, we realized that we wanted the trend kind of calculated in a more standardized way than, each goal model is going to be different, but the trend is going to take those goal models and find the trend over 5 years. So we realized that we could put this in a function in OHI core. This is actually an OHI core function. So we set how many years we want the trend to be. So this syntax will actually, if I see what this will give us 5 years that will calculate the trend. So if we look at what this looks like, head of our trend, this will again have these columns, like pretty minimalistic columns, region ID, score, and dimension. So this is what the trends look like for those 5 years for the first 6 regions. And then the very last thing that happens before this function is over is we're going to combine the status and the trend into a scores, something called scores. a scores object, which I can now explore down here, head scores. So this is going to have both status and trend as dimensions here. And then finally, this, this object scores will be returned. And if I run this right now, I think I'll get an error because this is something that is run from within a function. And what calculate all is going to be doing is it's going to be, for every single goal, it's going to be creating something called scores and then binding the next goal's scores every time. So it's going to kind of be this growing thing that will ultimately have all of the scores together. Okay, so that's what, that's a look inside functions.r. Again, so yeah, if you wanted to be modifying this and developing this goal model, you can again do that right from functions.r, and you can edit everything. And if you want to then test it and see how scores will calculate, we'll continue with the workflow. So let me go ahead and do this. I know we've only got 5 minutes left. So this will be a good way to end up here. But okay, so let me just, I saved this. I want to just remember what this edit was that I had just made to functions.r. I think that I had just added that OHI core. Okay, yeah, so I can see immediately what my edits are. So I've divided this by 2, which is what we wanted to do. And then I was just adding this as an illustration. So this is fine. I don't actually know what's going on this gray line, but I am not going to worry about it. It's something that Git is doing in the background, and I'm not going to worry myself with it. Okay, so just to, yeah, I'm going to just rerun this conf chunk again, just to make sure that it's all up to date. I don't need to restart RStudio every time, but I definitely want to make sure that I have the most recent conf information so that my that new update I made to the AO goal model is registered. So now when I run calculate all, again, it's going to go through all this stuff, and my scores.csv should show up again. And we can again look at this to make sure that we really still only expect the AO score status trend and scores to change. So again, like just to eyeball this, 93.69 for score 0, 96.85. So it was quite a difference to add that, to divide that by 2 at that point in the model. So if there was the reason I had done that was clear, I'd expect these scores to change, and then the overall scores will change, not by a ton. You don't expect the overall scores to change by that much here, and they don't. So yeah, we could, you could continue with this and replot the flowers and then commit and push this to GitHub. I think in the interest of time, I'll let you do that on your own. There was one more example that I'll let you also do on your own, but it was building on what we've done so far. The idea here was to actually, the AO model that we've been working on so far had 2 variables, this need and access, and what we were going to do was add a brand new data layer. So I'll let you do this on your own, and you can let me know if these instructions aren't clear. But so we were going to add something called poverty, and so you could walk through, there's a poverty script in the prep folder that you can run, and that will save a new file that you'll actually have to add a brand new row in your layers.csv. So you'll see how, you might be developing goal models that have brand new data layers that, that are much better representative of Kenya and Tanzania, and not just substituting data into existing goal models, but actually recreating goal models and having to have new data to match. And that's totally fine. This is how you do it when you add a new data layer. You have to remember it to register it in scenario data years.csv. And I need to obviously build out this section a little bit more, but what that would look like is when you open up scenario data years, it doesn't exist in this file yet. So you would have, what I would do would be to copy AO access for, as many years we'll just do them all just to keep consistent. You'd have to add this here and change each of these to AO poverty. So I'll add this to the book so that you can, that this is described, but yeah, so that you would do that there. Then you would reconfigure the toolbox, and you'd also have to update the AO goal model, and that would look like you would need to, first of all, read in this AO poverty data layer. And there's a bunch of different ways to do this. In this example, it's set up so that once you read in the first layer, AO access, when you read in the second one, you actually join them together into a single object. And then with the third, you join them again. So that's one way you can do it. And then you'll update the goal model itself. So this will walk through all the steps, and again, you'll in your Git tab, you'll be expecting functions.r to change and the data layer to show up. And so you can kind of track everything that way. Yeah, so I know that's a total whirlwind. How are you guys doing?
Yeah, doing okay.
Good.
I think everyone's hanging in there.
Good. Good. I think, yeah, there's a lot of steps involved, but if you kind of get into the habit of how the workflow works, I think it, yeah, it's kind of enjoyable.
Yeah, no, I think it'll take a bit of practice and everyone giving it a shot, but it doesn't look too complicated.
Yeah.
It's manageable.
Good.
I don't know if anyone has any questions at all. No, doesn't look like I can't see any questions.
Okay. Okay.
David?
No, it just obviously takes a lot of practice and repeating it to be able to do it.
Yep.
So
Yeah. Yeah, and as you will have questions, and as you have them, there's a bunch of ways to get in touch. You can email me. You can also, we have the forum. If you want to, if you want to see, you can. You can add a new issue here and ask a question, which will my team will see. If I don't see it immediately, somebody on my team can answer it. Depending on what the question is, you can Google it, and sometimes it will be an R question or a GitHub question, and that has many answers on the internet. And even if it's an OHI core or a Ocean Health Index question, if you Google it, often you'll find the answer either on our forum, or also another resource we have is the toolbox. In addition to the toolbox training, we've got the toolbox manual, which is kind of, it's all on one page. It's kind of like a huge amount of information, but searching here sometimes helps, and Google can find it as well. We're trying to keep like a troubleshooting section here, so if you get errors, there'll be solutions as you find them. So you will run into errors, and we're trying to help you solve them as quickly as possible. But don't hesitate to email me with, even if it, nothing is too small or too big to ask.
Maybe just one thing. Yes, hello, Julie.
Yes.
One thing that I noticed is that we have to reconfigure the toolbox so that it can match the goals that we have. Remember, this one, the demo has all the 10 goals. And for our case, we only have 3 goals. So we need to think about how to reconfigure this to match that.
Yes. So you can do a few different things. One thing you can do is you can leave all 10 goals and only update 3. That's fine. Or what you can do, okay, let me find, in our toolbox training book, actually, so we were working in chapter 8. Chapter 9 gets into removing goals and deleting goals that you're not using. So there's examples here about adding goals, and there should be one about deleting goals, and if there's not, I'll add it. But this next chapter will show you how to do that, and we can talk about what makes most sense for you. If you want, you know, ultimately, if you want a flower plot with only 3 petals, 3 goals showing up, that's fine. Or if you want to show, we could also show the other 7 petals, but gray them out, like, so that to represent that you are not assessing them, but that they are there, like as a next step. So we can talk about what makes most sense for you.
And in terms of, so because we're doing this at a sub-national level, so we have different regions. So the repositories are, because of the spatial shape files, the repositories have already been configured so that it's, or at least the data sets that can be been configured, so they're already broken down into the regions, or what is?
Yes, so let me show you your OHI-Science / I'll show you Kenya, for example. So this, you've got these same 2 prep and region repository folders. And in here, we can actually look at the spatial, here's where we can actually see this file. GitHub will show this, this is the shape file that I created for you guys. So this is what your regions look like, and you can click on them and see the names. So this is the EEZ. So these are the regions that right now are represented in your repository. Here's also the list of them. And so yeah, right now, this is your toolbox setup, and each of these layers right now, if we look at one of them, we can look at this access one that we've been looking at. They have the 6, they have, this is kind of extracted data from the global, so it's not, it's a kind of a default or dummy data at this point, but it's set up with 6 regions so that it will all, you can clone this repository right now and calculate scores and do everything that we just did, because it's set up for the correct amount of regions that it expects for Kenya.
Okay.
Yeah. Yeah. And like I said, yeah.
Yeah, what was the year 2013? Shouldn't it have been the latest global year, or?
Yes. So that's what that's why we had to create this scenario data years, because this the scenario year is 2017, but this particular data set was never updated. So 2013 is the best, but so that's unideal. We're hoping that there's a better way to represent this model in the future, but you can see for AO need a different layer. 2017, there is data that's updated every year, and there's a year lag. So this is kind of a totally confusing table, but the point of it is to be able to realize what year of data you're using for this assessment.
Okay.
Mm-hmm. Yeah. Yeah. And so this is for Kenya, and then Tanzania is the same. I guess this one we haven't done the shape files yet, so there isn't the the region one yet. Okay. But for each of these 2, I can let me go back to Kenya for a second. Right now, so in the settings tab, we can look at the collaborators. Right now, I've given some of you right now we've got the permissions for everybody here, and you guys actually can add new people because I've got you as administrators. I can update tabbies as well. I don't know why that's like that, but you can, if you need to add new people, you can write their GitHub name and it will try to find them, and then you can add them, so that everybody can be everybody can clone this directly from Kenya. From OHI-Science. You don't need to do that forking thing that we did in the example. This will let you guys all collaborate in the same place instead of working separately.
Okay. Great. So there's no further questions. I'd just like to say thank you very much, Julia, for waking up so early and such a thorough training.
Yeah, my pleasure. I was really happy to do it. I'm glad. Thanks everybody for sticking around and going through it with me. And yeah, please follow up with questions because I know you'll have a lot.
Yeah, no, I'm sure we will, and we definitely will follow up directly or through the forum.
Great, great.
Yeah. Yeah.
All right. Well, thank you so much. Have a good